Welcome to today's class. Today we'll be dealing on differentiation. Differentiation is an aspect of calculus that enables us to determine how a parameter changes with respect to another. Let's say y is expressed as a function of x. So dy all over dx is same thing as f prime of x. Alright, let's look at the methods of differentiation. The first method of differentiation is general method. Secondly, we have the first principle method. Thirdly, we have the chain rule. Which is also known as function of a function. Or function of several functions. Number 4, we have the product rule. Product rule differentiation. And then number 5, we have the quotient rule differentiation. And then finally, we have the implicit differentiation. In this class, we are going to be considering general method. Let's say y is expressed as a function of x and y equals x raised to power n. So if you differentiate y with respect to x, you would have, this is how general method works. You multiply x by the power and then subtract 1 from the power. So here we have n multiplied by x raised to power n minus 1. Let's take an example. Example 1. Let's say y equals 2x raised to power 4 plus 3x raised to power 3 minus 4x raised to power 2 minus 5x plus 7. And we are asked to differentiate y with respect to x. So we'll take it bit by bit. First of all, let's consider 2x raised to power 4. According to general method, you multiply x by the power and then subtract 1 from the power. So here we have 2 multiplied by 4. You attach x raised to power 4 minus 1 plus 3 multiplied by 3. You attach x raised to power 3 minus 1 minus 4 multiplied by 2, you attach x, raised to power 2 minus 1 minus, here x is raised to power 1, so we have 5 multiplied by 1, you attach x, raised to power 1 minus 1, and then plus 0. If you differentiate 7, 7 will give you 0 because 7 is a constant. If you differentiate a constant, it would give you 0. That's why we have 0 here. So dy all over dx becomes 2 multiplied by 4 is 8. Attach x, raised to power 4 minus 1 gives us 3, plus 3 multiplied by 3 is 9. Attach x, raised to power 3 minus 1 is 2, minus 4 multiplied by 2 is 8. Attach x, 2 minus 1 is 1, minus 5 multiplied by 1 is 5. Attach x, 1 minus 1 is 0, plus 0. So dy all over dx equals 8x raised to power 3 plus 9x raised to power 2 minus 8x. 8x raised to power 1 is the same thing as 8x, and then minus 5, because x is raised to power 0, and according to the zeroth law of indices, anything raised to power 0 is 1. X raised to power 0 is 1. 2 raised to power 0 is 1. 5 raised to power 0 is 1. So apart from 0, anything raised to power 0 is 1. So this is our final answer.